Good morning, students. I am taking up new chapter, 4 year series actually. Goodbye Richard 4 year series. Since series comes into the picture, so I must tell you something about sequence and series first before going to 4 year series. So let me take up sequence and series first. You are already familiar with these words, sequence and series. You have already done something regarding these things in your 11th and 12th class. So I will be taking up few things from the sequence and series. See, what is a sequence? A sequence is a mapping. So it's a mapping from the set of positive integers into a subset of real numbers. Okay, and sequence is symbolically represented in terms of this curly brackets. Say sequence an. This is the symbol. Sequence un, sequence vn. So these are the symbols usually denoted by curly brackets an. Okay. For example, you have the sequence n or minus n, 1 by n, minus 1 is power n plus 1 upon n. These are all sequences. N upon n plus 1, so on. So many sequences are there. Now, what I have said is that a sequence is a mapping from the set of positive integers into a subset of real numbers. Means its domain is always same. 1, 2, 3, so on. Set of positive integers. Now the range may vary. For example, for this n, for the sequence n, you have when n is 1, n is 1, n is 2, n is 2, n is 3, and so on. You have the same range and same domain and same range. Because you know every set is a subset of itself, so this is a mapping from the set of positive integers into a subset of real numbers. Okay, so you have a sequence of this type. For the sequence minus n, you can have when n is 1, 2, 3, 4, then for 1 you have minus 1 over here for the sequence minus n. Then minus 2, minus 3, and so on. So this is a subset of real numbers. So this is a sequence. For 1 you have minus 1, for 2 you have minus 3, minus 2, for 3 you have minus 3. Similarly, see for n equal 1 by n, you are taking 1 by n. So 1 by n. So what is the range? When n is 1, 1 upon 1, it is 1. When n is 2, this is 1 by 2. When n is 3, this is 1 by 3. N is 4, 1 by 4, and so on. So you have a sequence of this type. 1 by 1, 1 by 2, 1 by 3, 1 by 4, so on. Ultimately it goes to which number? It goes to 0. Not exactly 0 because n is 1, 2, 3, 4, so on up to infinity. Infinity is not included, so you have 1, 2, 3 natural numbers. You have to take natural numbers only. 1, 2, 3. So if I will take infinity, 1 by infinity is 0. So ultimately it goes to 0. Similarly, for n equal to minus n, you have taken for n minus 1 is power n. See, what is the range? N equal to minus 1 is power n. This one. When n is 1, it is minus 1. When n is 2, minus 1 is power 2, it is plus 1. When n is 3, minus 1 is power 3, it is minus 1. Then plus 1, minus 1, plus 1, and so on. So you have only two numbers, minus 1 and plus 1. Okay. Similarly, you can have for these numbers n plus 1 by n divided by n plus 1. Okay. Now, you can see from these examples, there are sequences of the form, okay, is a set of passenger and domain is same. For sequence n, you have the range is 1, 2, 3, so on. For minus n, minus 1, minus 2, minus 3, so on. For 1 by n, you have 1, 1 by 2, 1 by 3, so on. For minus 1 is for n, you have minus 1 plus 1, minus 1 plus 1, so on. Ultimately, only two elements, minus 1 and plus 1. Similarly, you can have for other sequences. Now, what is a bounded sequence? You can see all these sequences are, few are bounded, few are not bounded. Let me first tell you what is a bounded sequence. First, let me tell you what is bounded above. Bounded above. A sequence an is said to be bounded above if we can find a real number k such that an is less or equal to k for all k. For all n. Means a1 is less than k, a2 is less than k, a3 is less than k, and so on. For example, if you have this sequence, minus 1, minus 2, minus 3, minus 4, so on. This sequence is, okay, let me not take this sequence. Let me take this one. This will be easy to understand. This is a sequence. Let me take up the sequence, say 1 by 2, 1 by n. 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, and so on. See, this is a sequence. I can take a number k, say 1, such that each an is less or equal to this 1. You see, this is 1, this is 1 half, 0.5, 1 by 3, 0.33, so on. 1 by 4, 1 by 5th, ultimately it goes to 0. So every number, your a1, your a2, your a3, your a, and so on, each number is less or equal to 1. So this is a sequence which is bounded by 1. So this is a bounded sequence, but it is a bounded sequence bounded above by 1. Okay, you have 1, and lastly it may go to 0. Doesn't it? 1 by infinity, it goes to 0. So it is bounded above by 1, but it is also bounded below. You see, its range is 0 to 1 only. Maximum is 1 and minimum will be 0. 1 by 100, 1 by lakh, 1 by infinity, it will go to 0. So you can see this sequence 1 by n. It is bounded below by 0, and bounded above by 1. So what is bounded above? We can find a real number k such that an is less or equal to k. And what is bounded below? I can find a real number k such that an is greater or equal to k. For all n. See, I have taken 0, 0. So each an is greater or equal to 0. You see? Each an, 1, 1 half, 1 by 3, whichever is to the left of 0 or to the right of 0 over here, not over here, over here to the right of 0, it is less, this is greater or equal to 0, right? Everything up to 1, it is greater or equal to, it starts from 0 and ends with 1. Here it looks like it starts from 1 and ends with 0, but actually it is from 0 to 1. So it is bounded below by 0 and bounded above by 1. So such a sequence which is both bounded below as well as above, we say that it is a bounded sequence. So a sequence is said to be bounded if it is both bounded above as well as bounded below. For example, this sequence. See, 1 by 2. This sequence is bounded below by 1. It is not bounded above. You can see it goes up to infinity. So it is, the lower bound exists. Lower bound is 1. See, this is the lower bound. 1, 2, 3, so on. It is not bounded above. You cannot find a real number such that this is, if you take 100 upper bound, then 101 surpasses that. So this is only bounded below, not bounded above. Similarly, if you will take this one, -1, -2, -3, so on. You can see this is bounded above by -1. Every other element is less. So it is not bounded below. It is bounded above. This is bounded below. Right? Okay. Now this sequence, this is an oscillating sequence. It oscillates between -1 and +1. -1, +1, -1, +1. Although you have lower bound is -1, upper bound is 1. So it's a bounded sequence, but then it's an oscillating sequence. Okay. So you know this is what is the sequence? What is the bounded sequence? Bounded below, bounded above, bounded below, bounded above. Let me take up 2 more examples so that it will be clear to you. Let me take up a sequence n plus 1 by n. You see your an is n plus 1 upon n. This is nothing but 1 plus 1 by n. This is the sequence. So what are the elements of the sequence? Your domain is set of positive integers, and range, what is the range? You see 1 plus 1 by 2. 1 plus 1, it is 2. Your n is 1. Set of positive integers starts from 1. When n is 2, it is 1 plus 1 by 2. 1 plus 1 by 3. 1 plus 1 by 4. And so on. You can see one of the bounds is 2. Right? What will be the possible upper bound? What is the possible bound here? You see, it is 1 by 2, then 1 by 3, 1 by 100, 1 by 1000, 1 by lakh, 1 by infinity. So it will be 0. Ultimately, it will go to 1. Right? So its range is 1 to 2 only. So it is bounded below by 1, bounded above by 2. Right? Similarly, if I will take n by n plus 1, this is the sequence n plus 1 minus 1 upon n plus 1. This is nothing but 1 minus 1 upon n plus 1. Now what is the range? Domain is same, set of positive integers. What is the range? When n is 1, this is 1 minus 1 by 2. So it is 1 by 2. See, when n is 1, n starts from 1, 1 by 2. 1 minus 1 by 2, it is 1 by 2. Then, when n is 2, it is 1 minus 1 by 3. 1 minus 1 by 4, 1 minus 1 by 5, and so on. Ultimately, it goes to which direction? It goes to direction 1. Because 1 by infinity will be 0, it will go to 1 only. Right? So, it is what? It is from 1 by 2 to 1. See, this n up plus 1 by n. This is bounded below by 1, bounded above by 2. Right? It ultimately goes to 1. Now this is bounded below by 2, 1 by 2, and above by 1. So this is bounded. Right? This is the I think I have been able to tell you what is a bounded sequence, which is both bounded below as well as bounded above. Now I have one more thing to say. Monotonic increasing sequence, monotonic increasing sequence, and monotonic decreasing sequence. Monotonic increasing sequence. A sequence AN is said to be monotonic increasing, MI, monotonic increasing. If an plus 1 is greater than an for all an plus means second element is greater than first element. See, when n is 1, this is a2 is greater than a1 when n is 2. a3 is greater than a2 when n is 3. a4 is greater than a3. So, sequence an is said to be monotonic increasing if an plus 1 is greater than an. For example, the sequence n. See, 1, 2, 3, 4, so on. Is it monotonic increasing? Yes. Because second element is greater than third, greater than first. Third will be greater than this. Fourth will be greater than this, and so on. This is a monotonic increasing sequence. What about minus n? It is minus 1, minus 2, minus 3, so on. This is a monotonic decreasing sequence. Why? Because minus 1 is the biggest, minus 2 is short, minus 4, and this is minus so on. This will be bigger, this will increase, this will decrease, right? So a sequence an is said to be monotonic decreasing if an plus 1 is less than an, right? Actually greater or equal and lesser equal. But if it is strictly greater, then we say it is strictly monotonic increasing. If it is strictly less than, then we say it is strictly monotonic decreasing. For example, I have given two examples. Let me take up these two examples, which I have discussed just now. Let me take the sequence n upon n plus 1. Let me take up the sequence, say an is equal to, okay, let me take up this one, n plus 1 upon n. Now what about an plus 1? It is n plus 2 upon n plus 1. Let me take up the difference, an plus 1 minus an. It is